Hello everyone! In this video, we're going to go over the KutaSoftware free infinite PreAlgebra worksheet, two-step equations with integers. I'll leave a link in the description below so you know how to access this free worksheet. Now, our directions on this entire page are to solve each equation. And it's very similar to one-step equations with integers, except as opposed to it only taking one step to isolate our variable, it's going to now take two steps. So let me show you how we're going to do this in number one. Remember, our goal is to solve the equation. So to solve the equation, we need to figure out what our variable is. In the case of number one, our variable is r. Now, a good piece of advice for solving these equations is to think of our order of operation. PEMDAS, parentheses, exponents, multiplication and division, and then addition and subtraction, working left to right for each. When we solve these two-step equations, notice that r is divided by 10. If I then multiply by 10 to get rid of it, I'm also going to have to multiply the 4 by 10. So a good piece of advice I can give you is to do the opposite. If you're trying to isolate a variable and there's addition or subtraction somewhere in your problem, as well as multiplication and division, start with that addition and subtraction. Move that to the other side, and it will make this process a lot easier. So for number one, we're going to start by subtracting 4. And whatever we do to the left-hand side of our equation, we need to do to the right-hand side. So when I subtract 4, notice that 4 minus 4 goes to 0, and 5 minus 4 goes to 1. So I'm going to have 1 on my right-hand side and r divided by 10 on my left-hand side, because 4 minus 4, that gave me a 0, and r divided by 10 plus 0, well, that's just r divided by 10. So that was our first step, was to move the 4 to the other side, and our second step is going to be, well, multiply both sides by 10. Since r is divided by 10, we need to multiply by 10 in order to get the identity. And what I mean by that is that 10 times 1/10, or 10 divided by 10, goes to 1. And 1 times r is just r. But remember, whatever I do to the left-hand side, I do to the right-hand side. And I may sound like a broken record on this, but it's very important to remember that because this is an equation, whatever I do to the left, I need to do to the right. So I'm going to multiply my right by 10 as well. So in the case of number one, r is equal to 10. Now, I want to show you that helpful tip that I gave you in the beginning, you can choose to ignore it if you want. It's just going to be a little extra work. So let me rewrite this problem. We have r divided by 10 plus 4 equals 5. Now, I can choose to get rid of the 10 first, but when I multiply both sides by 10, I'm not just multiplying this r over 10. If I'm multiplying the entire left-hand side of my equation, I'm going to be multiplying my r over 10 and my 4. So then this becomes r, because 10 times r over 10 is r, so I distributed it there, but I also need to multiply it by 4. So that'd be r plus 40, and that's all equal to 5 times 10, which is 50. Now, isolating my r, I'm going to subtract. So I need to subtract 40, and look, r is equal to 10. So you can do it either way. You're going to get the same answer. It's just you're going to be working with larger numbers if you choose to multiply and distribute it out. It's just a little bit of extra work. So I recommend just sticking with that tip that I gave you in the beginning to make these problems easier. So let's continue on to number 2. In number 2, we have n divided by 2 plus 5 equals 3. What are we going to do first? We're going to move this 5 to the other side so that we can begin to isolate our variable. So subtracting 5 from both sides, since the 5 is added, that's going to give me n divided by 2 on my left-hand side equals 3 minus 5. That's a negative 2. That was my first step right here. Now my second step, in order to isolate my n, I'm going to, if n is divided by 2, I need to multiply both sides by 2. So 2 cancels out with 2 to give me that n is equal to negative 2 times 2, which is a negative 4. So negative 4 is my solution in number 2. And again, what we mean by solution is that's what n is equal to. We can plug -4 right on into this equation up here, and look what we're going to get. -4 over 2 plus 5. What does that equal? It should equal 3 if we did our work correctly. -4 over 2 is a -2 plus 5. That does indeed equal 3 because 5 minus 2 is 3. So that's what we mean when we say solve the equation. We're just trying to figure out what value makes this true. So for example, if I thought n was equal to 2, 2 divided by 2 is 1, 1 plus 5 does not equal to 3. So our value has to be a -4. Let's move on to number 3. For number 3, we have that 3p minus 2 equals a -29. Let's start out by moving that -2 to the other side. So if the 2 is subtracted, in order to cancel it out, we're going to add it to our other side. -2 plus 2 is 0. 3p plus 0, or 3p minus 0, is 3p, and that's equal to -29 plus 2. We're in the negatives, but we're moving a little bit closer to that 0, so that's a -27. There's my first step. My second step, in order to isolate that variable, divide by the 3. When I divide by 3, 3 divided by 3 is 1. We'll have p on our left-hand side equal to negative over a positive is a negative. 27 divided by 3 is 9. So -9 is our solution in number 3. In number 4, you may be wondering, well, how exactly is this a two-step equation? But look at this r. It's not a positive r, and when we solve for our variable, we want that variable to be positive. So pretend that there's a -1 r right out in front. So there's a 1 in front of that r, making this a -1 r. So we're going to start, though, by subtracting this 1 over here. So subtracting 1 for both sides. 1 minus 1 is 0, so I still have my -r, and that's going to be equal to -5 minus 1, which is a -6. Now we're very close to solving this. We need to do one more step. And if this is a -r, in order to cancel out the negative, we can either divide by a -1 or multiply by a -1. It really doesn't matter. All we're doing is switching the signs, and we're switching the signs on both sides of the equation, because the left-hand side equals the right-hand side. Whatever we do to the left or right, we do to the opposite, the right or the left. So let's multiply by a -1. -1 times a -r is a positive r. -6 times -1 is a positive 6. So 6 is our solution for number 4. In number 5, we have k minus 10 over 2. Now, look at this. K minus 10 is in the numerator. So if we tried to start by adding 10 to both sides, that's not going to work because 10 is over top of that too. So if I was to split this fraction up, it would really be k over 2 minus 10 over 2. K over 2 minus 5. So then I would need to add 5 to both sides. But this is a good case where, think about that numerator. That numerator technically has parentheses around it because we have to do what's in the numerator all together. So remember, if we're working backwards with that PEMDAS, parentheses is one of the last things we deal with. So let's multiply first. So multiplying both sides by 2 is going to make this problem simpler. 2 divided by 2 is 1. So we have k minus 10 on my left-hand side, that was what's in the numerator, equals -7 times 2, which is a -14. Now, one more step. We're going to add 10 to both sides of our equation. K minus 10 plus 10 is k, and that's equal to -14 plus 10, which is a -4. So -4 is our solution for number 5. And just to quickly show you, you'd get the same result if we did do addition or subtraction first. We're going to write k over 2 minus 10 over 2, which is really -5, equals negative 7. So I'm going to add 5 to both sides in order to get rid of that 5. So I'll get k over 2 equals negative 7 plus 5, which is a negative 2. Then I'll multiply by 2 to isolate my variable. K equals a negative 4. Lots of times with these two-step equations, or when we get into multi-step equations, which will be more than just 2 steps, there's going to be multiple ways to do a problem. So if you've attacked this problem in a different manner, that's okay. But you will get the same exact result. So if you don't get the same answer, maybe something went a little wrong on the way. But go back, double check, and work through the steps in a different way if you're struggling. Let's move on to number 6. In number 6, same kind of deal. You can think of this n minus 5 having parentheses around it. So what we're going to start with is by multiplying by 2. And that's in order to cancel the 2 out of that denominator. So we'll get n minus 5 equals 5 times 2. 5 times 2, that's simply 10. Now to finish this problem out, add 5 to both sides so that we isolate that variable. So n is going to be equal to 15. So 15's our solution in number 6. Moving right along to number 7, we have negative 9 plus n over 4 equals a negative 7. Notice that this negative 9 is not in that numerator, so we do not need to divide it by that 4. So I'll start by adding 9 to both sides in order to cancel out that negative 9. So I get n divided by 4 is going to be equal to negative 7 plus 9, that's going to be a positive 2. Because we're starting in the negatives at negative 7. Adding 7 to that gets us to 0, but we need to add 2 more to get to that total of 9. So n divided by 4 equals 2. One more step, multiply by 4. So n is going to equal 8. And lots of times, I don't know if you've noticed it, but it helps to keep your equations in line. Keep that equal sign lined up so that you can keep your left side separate from your right side and track your steps. Just another helpful tip. But let's move on to number 8. And number 8, that 9 is in the numerator, so it is indeed divided by 3. So what I'm going to do is I'm going to start by multiplying both sides by 3. When I multiply by 3, I'll get that 9 plus m equals 2 times 3, which is 6. One more step, subtract the 9 from both sides. 9 minus 9 is 0, plus m is m, and that's going to be equal to 6 minus 9, which is a negative 3. So negative 3 is our solution for number 8. And again, once we do that first step, this one-step equation should just be a review. So if you still need help on that, go back to that previous worksheet that I went over. But for now, let's continue. We're going to start by multiplying by this 22. So we're going to multiply both sides by 22. When I multiply both sides by 22, 22 divided by 22 is a 1, and negative 5 plus x divided by 1 is negative 5 plus x. And that is equal to negative 1 times 22, which is a negative 22. One more step, to isolate this variable, we're going to have to add 5 to both sides to get rid of that negative 5 on my left-hand side. X is going to be equal to negative 22 plus 5. Think about adding 2. That will get us to negative 20, and then we need to add 3 more to get that full amount of 5. So that's going to be a negative 17. So negative 17 is our solution for number 9. For number 10, 4n minus 9 equals negative 9. What's nice about this problem is, look at this. When we add 9 to both sides, negative 9 plus 9 is 0. So we're really going to get 4n equals 0. And if 4n equals 0, think about it. 0 divided by any number is 0. So when I go to divide by this 4, it doesn't even matter because n has to be 0. If n times some other integer that's not 0 equals 0, well, n has to be 0. So n is 0 in number 10. Let's move on to number 11. In number 11, we're going to start out by getting rid of that denominator, since x plus 9 is my entire numerator. So I'm going to multiply both sides by 2 to get that x plus 9 is equal to 3 times 2, which is 6. One more step, subtract the 9 from both sides. So x is going to be equal to 6 minus 9, which is a negative 3. So negative 3 is my solution for number 11. In number 12, what can we do? Start by multiplying by that 11. That is in the denominator of my fraction, and my fraction is my entire left side. So I'm going to start by multiplying both sides by 11. So that's going to leave me with negative 12 plus x equals negative 3 times 11 is a negative 33. Then I'll add 12 to both sides as my final step. Because, look, that isolates my x on my left-hand side, and that's going to be equal to negative 33 plus 12. Doing this in our heads, negative 33 plus 2 is negative 31, plus another 10 is going to be negative 21. So negative 21 is number 12. For number 13, we've got negative 4 plus x divided by 2 equals 6. Let's start by multiplying by 2, since that entire left side is a fraction. So multiplying by that denominator, 2, we'll get that negative 4 plus x equals 6 times 2, which 6 times 2 is 12. So now all we need to do is add 4 in order to cancel out that negative 4 from my left-hand side. Whatever I do to the left, I need to do to the right. So x equals 12 plus 4, which is 16. Now moving on to the last problem on this page, number 14. Number 14, look, that 3 is in the denominator, but our left-hand side isn't an entire fraction. So we're going to start by moving this negative 5 and canceling it out. In order to do that, we'll add 5 to both sides. So negative 5 plus 5, that's 0. 0 plus n over 3 is n over 3, and that's equal to 0 plus 5, which is 5. One more step, multiply by 3 to get that n is equal to 5 times 3, which is 15. So 15 is our solution for number 14. Let's move on to our second page now. Starting off our second page with number 15, we're going to have p divided by 4 plus 8 equals 7. Let's start by getting rid of that 8 since it's added to our variable that's divided by a number. So subtracting 8 from both sides, we're going to get that p over 4 equals 7 minus 8, which is a negative 1. One final step, multiply both sides by 4. So we get that p is equal to negative 1 times 4, which is a negative 4 for number 15. In number 16, that 4 is dividing the n, but not the 9. So we're going to start by subtracting 9 from both sides. 9 minus 9 is 0. 0 plus n over 4 is n over 4, and that's equal to 15 minus 9, which is 6. One more step in order to isolate that variable n, multiply by 4. N is going to be equal to 6 times 4, which is 24. And remember, how do you double check? Plug in right on in. So if we have 9 plus n over 4 equals 15, is this true? Well, we're plugging in 24 for n. So we have 9 plus 24 divided by 4 is 6. Does that equal 15? Yes, it does. 9 plus 6 is indeed 15. So n is correct as 24 for number 16. In number 17, we're going to start by subtracting the 6. 6 minus 6 is 0, so we have x over 2 equals 4 minus 6, which is a negative 2. Last step, in order to isolate the x, we multiply by that denominator. 2 divided by 2, or 2 times 1/2, is going to equal x, and that's going to be equal to negative 2 times 2, which is a negative 4. So negative 4 is my solution for number 17. And number 18, look, that 3 is dividing both the b and the 11. So we're going to need to start by multiplying by 3. When we do that, the 3 cancels out on my left-hand side to leave me with b plus 11. So leaving me with just that numerator. And my right-hand side is negative 2 times 3, which is a negative 6. One more step. Pretty simple just to subtract the 11. So b is going to be equal to negative 6 minus another 11. That's negative 17. So just to switch things up a bit, let's just think about number 19 without even doing any work. If this right-hand side has to equal negative 4, and we're dividing this numerator by 3, what's the only number divided by 3 that gives us negative 4? Well, it's got to be a negative, right? So we know that our numerator is negative. And what divided by 3 gives us 4? That's 12. So negative 12 divided by 3 gives us a negative 4. That means that a minus 10 is equal to a negative 12. How is a minus 10 going to be equal to a negative 12? Well, we already are subtracting 10, so we need an extra negative 2. So a is going to be negative 2. Negative 2 minus 10 is a negative 12. Divide that by 3, we get our negative 4. So feel free to think about these in your head, but don't forget you're going to need to show your work so that your teacher knows that you understand how to solve the problem. So let's quickly go through the work. We can multiply both sides by 3 at the start to get the a minus 10 equals what? That negative 12. Then we add 10 to both sides to isolate the a. So a is going to equal negative 12 plus 10, a negative 2. And that's what we got when we did the problem in our heads. Let's move on to number 20. Number 20 says that negative 12r plus 4 equals 100. We're going to start by getting rid of this positive 4. So we're going to subtract 4. So we have negative 12r plus 0 equals 100 minus 4 is a 96. Negative 12r plus 0, well, that's just a negative 12r. So all we're doing is dividing both sides by negative 12. So that leaves us with r is equal to 96 divided by negative 12. That's a negative. 96 divided by 12 is 8. So negative 8 is our solution for number 20. For 21, m divided by 16 minus 9 equals negative 8. Let's start by adding 9 to both sides. This is going to help us in isolating our variable. So we'll have m over 16 on our left-hand side equal to negative 8 plus 9, which is a positive 1. Now, just simply multiply both sides by that denominator, which is 16. So m is going to be equal to 1 times 16, which is 16. Moving on to number 22, we have negative 7 plus 4r equals negative 15. Let's start by adding 7 to both sides in order to cancel out that negative 7. So we'll have 0 plus 4r, which is 4r, and that's going to be equal to negative 15 plus 7 is a negative 8. Last step, divide by that positive 4. That's going to leave r on my left-hand side equal to negative 8 divided by 4, which is a negative 2 for my right-hand side. For number 23, what do we want to start by doing? Well, m minus 13, that entire quantity is divided by 2. So we're going to get rid of that 2 first by multiplying by 2. And we're going to multiply by 2 on both sides of my equation. Whatever I do to the left, I do to the right. Whatever I do to the right, I do to the left. So we're going to have m minus 13 equals negative 8 times 2, which is a negative 16. Last step, just add 13 to both sides because negative 13 plus 13 is 0. So we have m on our left-hand side equal to a negative 3 for our right-hand side because negative 16 plus 13 is a negative 3. For number 24, negative 5x plus 13 equals negative 17. Let's get rid of this 13 first. We'll do so by subtracting 13 from both sides. So we'll get negative 5x equals negative 17 minus 13. We're going further into the negatives. Negative 17 minus the 3 is going to be negative 20. Minus another 10 is a negative 30. So we have negative 5x equals negative 30. Divide by negative 5. Because we want that x to be positive, we need to divide by negative. And we want x all by itself, so we need to divide by the same quantity that's multiplied by it. So negative 5 divided by negative 5 is a positive 1. 1 times x is x. And that equals negative 30 divided by negative 5. Negative divided by a negative is a positive. That's a positive 6. For 25, k plus 10 divided by negative 2 equals 5. So, multiply both sides by a negative 2. In doing so, my negative 2's will cancel out to leave k plus 10 equal to 5 times negative 2, which is a negative 10. Now what am I going to have to do? Subtract 10 from both sides. So we'll get k equal to negative 10 minus another 10. That's going to be a negative 20. So k equals negative 20 in number 25. In number 26, we're going to start by multiplying by that denominator, which is a negative 2. So multiplying by negative 2 will leave me with just my numerator on my left-hand side, which was the entire quantity p plus 8, and that's going to be equal to 10 times negative 2, which is a negative 20. Now, subtract 8 from both sides. Negative 20 minus 8 is a negative 28. So p is equal to negative 28 for number 26. Moving on to our second to last problem on this worksheet, number 27. And if you've stuck with me this far, go ahead and click that like button. And if you can think of anybody that would also find this video helpful, feel free to share it with them. But let's continue on. We're going to start by getting rid of this minus 19 by adding it to both sides. So when we add 19 to both sides, we'll have negative 14r on our left-hand side equals 303 plus 19 is going to be 322. 3 plus 9 is 2, carry the 1, 1 plus 1 is 2, then 3 plus nothing is still 3. So 322. Now we're going to divide by a negative 14. So we know our solution is going to be negative, but what's 322 divided by 14? Well, let's first do it in our heads, and then we'll double check with some long division. What's a friendly number that we can easily use? We can multiply 14 by 10. So 14 times 10 gives us 140. But that's nowhere near 322. So if we multiplied 14 by not 10, but by 20, that's going to double it. And doubling 140 is going to give us 280. So we're getting closer, but not quite there yet. So we're at 20 right now. How many more 14s do we need? 2 would be 28, which would get us to 308. Oh, and then we need one more 14 to get 322. So we need 23 14s to get to 322. So this is a negative 23 for number 27. And again, let's just double check quickly with some long division. 322 divided by 14. 14 goes into 2 times. 2 times 14 is 28. So we're going to subtract that. That leaves us with 4. Bring down the 2. 14 goes into 42. How many times? 3 times, because 14 times 3, 2, carry the 1, 1 times 3 is 3, plus 1, that is indeed 42. So negative 23 is our solution for number 27. Finally, our last problem, number 28. We're going to start this one off by adding 5 to both sides. In doing so, we'll have x divided by -4 equals -8 plus 5, which is a -3. Then we're going to multiply by that denominator of -4 because -4 divided by -4 is a +1, and 1 times x is x. So x is equal to -3 times -4, which is a +12. And with that, we wrap up this free KutaSoftware worksheet. If you have any questions, please feel free to leave them in the comments below. And as always, don't forget to like, subscribe, and share. All likes and subscriptions are greatly appreciated.